Welcome to Study Loop.
Hello friends, here it is given a vapor compression. A refrigeration cycle with refrigerant R22 having fluid property as follows. Temperature in degrees Celsius, saturated pressure in kilopascal, thermal capacity of the fluid, thermal capacity of vapor, and entropy of vapor, kilojoule per kg per Kelvin. Temperature minus 5 degrees Celsius. Saturated vapor of the fluid is 421.2 kilopascal. Heat capacity is 38.76 kilojoule per kg. 748.1 of the vapor, and entropy of vapor is 0.9344. At 45 degree, pressure is 1728 kilopascal. Fluid thermal capacity 101. Vapor thermal capacity 261.9 kilojoule per kg, and entropy is 8682. We have to find first sketch, hardware, and TS graph, and we have to calculate heat absorbed at low temperature. C. Heat transferred at high temperature. Let us hear the hardware of it. There is a condenser, compressor, compressor pump, state 1, state 2, work input, rate of doing the work, power input, evaporator. This is at 45 degrees Celsius. Evaporator at minus 5 degrees Celsius. That is expansion valve. heat transferred at high temperature, heat absorbed at low temperature, work done. Now entropy and temperature graph. State 1, state 2, acentropic process in state 2, 45 degrees Celsius temperature. Third state, fourth, -5 degrees Celsius. Rate of flow of heat at low temperature, rate of flow of heat at high temperature, work input, power input you may call. This is fourth isentropic process. This is fourth process. That's all for it. Thanks for watching it. Let me correct. Here it is temperature and this is entropy. Now B part. The properties of fluid are given in the problem. H4 to be equal to H3, HF at the rate of 45 degrees Celsius, 101 kilojoule per kg. H1 is equal to H vapor at the rate of -5 degrees Celsius, 248.1 kilojoule per kg. The heat absorbed by refrigerant in the evaporator will be H1 minus H4, 248.1 minus 101, that is 147.1 kilojoule per kg. C. Coefficient of performance of air condition is equal to SEER 1 watt upon 3412 VATU per hour, that is 16 VATU per hour upon 3.412 VATU per hour, so it is 4.689. The work input to compressor, coefficient of performance of refrigeration, heat transfer at low temperature upon power input, work done in input. So from here work input you will get heat transfer at low temperature to coefficient of performance. Heat transfer is 147.1 kilojoule per kg and it is 4 coefficient of performance 4.689, so you will get 31.4 kilojoule per kg. The enthalpy at compressor axis is so H2 will be H1 plus H1 is given 248.1 and work input is 31.4. So you will get 279.5 kilojoule per kg. The heat rejected from refrigerant in condenser, that is heat transfer at high temperature, H2 minus H3, 279.5 minus 101, that is 178.5 kilojoule per kg. That's all for this problem. Thanks for watching it.